Hey guys, we're going to start looking at conducting statistical tests, whether it's a z-test, t-test, testing against one sample mean against a known population value, comparing two groups. Later on, we're going to look at paired differences, which will be like testing before versus after. In some of the previous videos, we did confidence intervals. Those tie in a lot with statistical tests. In fact, to me, confidence intervals just gives a really good numerical backing to the outcome of a test. This video, the purpose of it really is just to get you introduced to some vocabulary. What's a null hypothesis? It's a working hypothesis making a claim about a population parameter in question. And just an example of that would be, say, and I'm just going to make up something, like say the length of all calculators made in the month of August are 6 inches long. Your null hypothesis would agree with what's already established. An alternative hypothesis would be like, I don't agree with that, so I'm going to take a sample of 400 calculators and measure them, and I'm going to claim that calculators are shorter than 7 inches in length. And then so you would make an appropriate alternative hypothesis, which is your research question. And that can be phrased as shorter, longer, less, more. There are two-tailed tests that are indifferent, like not equal to, or just simply the phrase different, or word different. When we start conducting these tests, we're going to look at the information given in the problem. We're going to write down a null and alternative hypothesis, and we'll do a lot of practice, so you'll get used to seeing it. The errors that can be made, because anytime you don't know the entire population and you're relying on a sample, you can make errors by chance. A type 1 error is if the null hypothesis is true, but your statistics lead you to rejecting it. So a case of that, if you stay in line with the calculator analogy, which was a silly analogy, but it's just to hopefully illustrate a point. A type 1 error with respect to the calculator would be, and actually let me write these out so that we have written. And this is the analogy that all calculators are 7 inches long. H sub 0 is null hypothesis. The length of all calculators is 7 inches. Maybe we want to argue that calculators are shorter in length than 7 inches, then you may also, depends on what stats book you use, see H sub A, alternative hypothesis. But if you say shorter, then you would just say mu is less than 7 inches. All right, so what is it? A type 1 error would be if the null hypothesis is true. For example, all calculators made in the month of August, I think that was the month I used, were 7 inches long. But when you conducted your test, your alternative came up with all calculators being shorter than 7 inches in length. So a type 1 error is your data leads you to this, when in fact this one is the one that's true. A type 2 error is just the opposite. That's when you don't reject the null hypothesis when it's false. So that would be a case of saying all calculators are not 7 inches, but your data says that it is. that would be a case of a type 2 error. A type 1 error is called a miss. It's when the initial guess is already true, but your data leads you to believe something else. It's kind of like getting a false positive. A type 2 is when your null hypothesis is false, but data suggests it's true. Significance level of a test. Level of significance will be denoted with alpha. That's the probability of a type 1 error that you're allowing yourself because you know that you're human and you don't have all the data from the population. You just take a sample and you hope your sample is a representative that will help you decide whether to agree or disagree. It's not proof, it's just, does my data, is it strong enough to suggest one over the other? The alpha level, you will see that in every problem. That's what you're comparing your sample data to. Type 2 errors denoted with a beta. Let me write that just a little bit larger. So alpha is the probability of a type 1 error. Beta is the probability of a type 2 error. If we reject a null hypothesis, does this mean that we've proved it to be false beyond all doubt? That is no way. Don't even worry about using the word prove, because this is just arguing your data that you've collected over what's already established, if there's data already established. Okay, so let's look at how to write some of these up. This is another example. The body weight of a healthy 3-month-old colt should be about 66 kilograms. This is established data, so your null hypothesis will agree with what's already established. Part A, if you want to set up a statistical test to challenge the claim that mu equals 66 kilograms, what would you use for the null hypothesis? You would use exactly that statement. Your null hypothesis, don't disagree with what's already established. Whether it's true or not, it will agree with the data already established. In Nevada, there are many herds of wild horses. Suppose you want to test the claim that the average weight of a wild Nevada colt at 3 months old is less than 66 kilograms. What would you use for the alternative hypothesis? Just let the wording help you out. Less than, mu is less than 66 kilograms. Again, you're going to be comparing your data to the population of all. Suppose you want to test the claim that the average weight of such a wild colt is greater than 66 kilograms. Then your alternative hypothesis will have a greater than symbol. And then finally, suppose you want to test the claim that the average weight of a wild colt is different. Not committing to one way or the other, different. What would you use for your alternative hypothesis? Then you would just simply use a not equal to. The symbol in your alternative hypothesis, whether it's less than, greater than, or both, will just be based on what symbol you use in your alternative hypothesis. Less than is left-tailed, greater than is right-tailed, and indifferent or just different, not equal to, where you don't commit to one way or the other, that is a not equal to. And then on the next few videos, we're going to look at actually conducting some statistical tests using SALT and the graphing calculators.